Welcome back, guys. Today we are going to solve LeetCode problem 1041, a robot bounded in circle. So on an infinite plane, a robot initially stands at location 0, 0 and faces north. The robot can receive one of the three instructions. G is go straight 1 unit, L means turn 90 degrees to the left, and R means turn 90 degrees to the right. The robot performs the instructions given in the order and repeats them forever. So which means that it will just loop into the instructions and it will keep performing the instructions again and again. So return true if and only if there exists a circle in the plane such that the robot never leaves the circle. What this means is if the robot is standing from 0, 0 location, then it will perform the instructions in the set and it again reaches that 0, 0, 0, 0 coordinate, right? And again it starts performing. So basically it's kind of forming a circle when it is performing those instructions. So these are some of the examples that are given to us here. So let's just take these examples over here and we will discuss how we can solve this problem. So as the best, like easiest way to solve this problem is just kind of simulating that robot is in the plane with x and y plane, and it is standing at the like a 0, 0 location, right? So this location is 0, 0, which is the xy plane, and what we will be simulating is we will simulate the instructions and we want to check if it is reaching back to the 0, 0 location again after performing those instructions. So let's just look at this problem, like GGLLGG, these are the instructions given to us. So the robot is facing north, right? So robot face is on the north side in the beginning. This is the north side, right? So it starts from the 0, 0 coordinate and it goes one distance here. So it reaches here. So after 1G, right? And after second G, again it will go here and it reaches here. So this is second G, right? Because two distances it will go. Then after that it will execute L. L means it will turn its face to 90-degree left basically. So it's from north it will go to west, and again L means again L, right? Then it will from west its face will go to south, right? Because now it will again move 90 degrees left. So again it will start moving into now the south direction and it will go G, and G means two distance. So again it starts moving like here, and from here again one distance and two distance here, right? So again it means that a robot is again reaching back to the distance like the coordinate 0, 0 where it started. So basically as you can see the path is like this, right? It goes here and again it comes back here. So it is kind of a forming circle. So that's why we have to return true here, right? So we will just return true. It is forming a circle because it is coming back where it started, and it will just start execute these instructions in cycle. So it will again like it will like do this kind of thing, like it will go here and again come back here, right? So it's cycle. So now again another example it's given is a GL. So again the robot is standing here and it will 0, 0, right? We know, right? This is a 0, 0, this is XY location. So now it will go 0, so it will go now north side 1 because of this G. So now it reached here and it is executing L. L means it is changing its face from north toward west. So now its face is toward west, so it will again do G, right? So it will go one distance toward west. So this is west. So again it will perform GL, right? Because it is in loop. So means it will reach to here and it will again perform L. L means from west it's facing now south, right? South. So it will again start going south and it will go one distance here now and it will reach here and it will again now from south it will start L. L means south. L is basically east, so it's facing east, so it will again go one distance here and as you can see, it reached where it started, right? It again reached the coordinate 0 0 where it started. So basically, as you can see, this is a kind of a circle, right? That robot is basically bound with a circle. So it is starting and it is coming back to the same point, again starting, again coming back to the same point, as it is performing the like these instructions in a loop, right? So this is the case, and the other example is when is the example when it will not reach to the, when it is not bound to the circle, right? So let's take one other example. So now there is an example where we have just g, right? G and G basically. So G in infinite loop. So it will start from here, it will go here, it will reach here. Now again it's facing north. So again after G it will go here. So again at this point it is facing north. So it will keep going in north direction, right? Like this. But it will never be able to come back where it started from. So in that case we have to return false. So that's what we will be doing. So so this is a general approach of how the problem we have to solve. So now how we will be solving this problem in Java. So we will be using, first we have defined a class called as location. So location will capture the x and y coordinate of the current position of the robot, and like it has this just one constructor is there, and this is our actual method where we have, first we have created one location map. So location map will be like, if you are going in the north location, and if you are executing G, right, in the north location, then we will be adding like 0 and 1. So we will add 0 to x and 1 to y basically. For example, this is our plane, right? So if robot is here, and if so now it's facing north, right? So it's facing north. So when G is coming, then we, from this 0 0, we will on 1G, right? G is the instruction. So we will reach here. So we, what we will do is we will add 0 to the x and 1 to the y, right? Because that's what we want to do. So that's what we are doing here. We are adding 0 to the x, 1 to the y. Now if we are going south, so now let's say we are here, we are at a 0 1 and we are going south, right? So south means we will add 0 to x coordinate and we will subtract 1. So that's what we are doing, right? 0 to x coordinate and we will subtract 1 from y coordinate, 1 from y coordinate. So y will become again 0. So as you can see, it is kind of a easy mathematics. So this is kind of how we want to do the like movement of the robot, right, as it goes. Basically we are simulating this G part actually, right here. And then we have created a direction map. So direction means like you have a string and array list of strings. So for every direction, this is your current direction, and if you get L, for example, if you are looking at north, right? Now for example, you are looking at north, and if you get L here, then you, what you will do, you will go 90-degree here, right? Which means that you are going towards west. So here as you can see, the first part is L and second part is R. So when you are doing R from north, you will go to east, right? So here we are going west, but if you are doing R, then you will go to east, right, on R. So basically that's what we are simulating, this L and R operation here. So this is for 4 direction, right? North, south, east, west. So the first in this list, the first is value will be for L and the second value is for R. So we will start with current location as north, and we will start with current coordinates at 0 0, and we will read through instruction in the for loop and we will execute the instructions here. So if we are getting G, then we will just modify the x and y coordinate of the current location according to the the current location direction, right? Then we will use this location map for example, if you are going north, then we will just use 0 1, means we will add that 0 and 1 in x and y values basically. So that's how we are simulating the movement of the robot in the G. And if we are getting L, like uh, L, basically this L, right, or R, then we are using our direction map. So in direction map, if it is L, we will get our current location direction here. Like for example, if it is north, then we will just get 0 of from this list, means we will get west here, right? If it is R, then we will get a 1 from this list here, which is east. So as you can see, we are getting 0 here because we are doing L, and otherwise if we are doing R, we will get 1 actually from that list. So this is the way we are simulating the L and R operation. So we will keep doing these operations in the loop, in this for loop, and at the end we will check if the current location means the basically the final location that the robot reaches, if it is 0 0 again, right? If it is again 0 0, means we will return true. But if the current location is not 0 0, but if its direction is not north, right, the last time the direction is not north, for example in this case, right, GL, here we will be only doing one G and one L, right? We are not doing like in a loop basically in the Java program. It's not like a loop that we are doing GL GL GL, only one GL we will do. So in that case, we will just end up with the robot is facing direction at the end is west, right? After doing GL, the robot direction will be facing west. So that is also we will be considering as true, because that is if you execute this in a loop actually, like not just GL but GL 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 4 times, then you reach 0 0, right? So that's why we will check if its facing is not north at the end, then we will return true basically. So as you can see, current location is not facing north, we will return true, and at the end we will return false. So this is a simple Java implementation. So as you can see, this location map, we are going to create, like simulate the G uh, instruction, where we have to move one unit, but we have to, how we will be moving that one unit is we will be adding this 0 and 1 to corresponding x and y coordinate. That's what we will be doing, right? As we are doing here basically, you can see, right? And it is based on the current direction, right? So it will automatically know the current direction. If it is north, then it will add 0 to x and 1 to y. If it is south, then it will add 0 to x and it will subtract 1 from y. So that's how it will work. So and we have defined one direction map here. It is string and array list of strings. This direction map we will be using to simulate L and R part, right? Where basically the robot is not actually moving, but it is just changing its facing direction. So in the beginning it is facing north, but if you do L, then it will start facing west, right? It will turn 90 degree to left, like that basically. So that part we are simulating here. So I think I explained it pretty detail about how the robot like will be moving and executing the instructions, and how at the end we will be checking its current location or current location direction to decide if the robot is bounded in circle. So this is how you can solve this problem in Java. So as you know, I often create videos regarding Java J2 interview questions as well as LeetCode solutions. So please subscribe to the channel and hit the like button, because this helps the channel to grow and reach to more people. So thanks for watching the video.